Welcome to another coding tutorial, and in today's video, I'm going to show you how I mashed up 3 of my past tutorials into this one. This tutorial is inspired by this sketch by Ivan Rudnicki, who created it as part of the weekly Creative Code Challenge hosted inside Burp's Nest, which is a Discord channel run by Raphael de Corville. Every week, people vote on a theme, share sketches, and on Sundays, he reviewed it live on Twitch. It is definitely a fun way to get your creative juices going, so I recommend checking it out. This piece combines techniques from 3 of my past tutorials, so if you like this one, be sure to check those out too. A Truchet tile is a square tile with a pattern that changes based on how it's rotated, creating complex designs from simple rules. So in this tutorial, we're going to be using an arc version, which uses quarter circle curves in opposite corners to form flowing paths when tiled. We're going to start by creating this one Truchet tile. So how about we declare a few variables? Let's start with x and y. And I'm going to do it a little bit differently this time than my previous tutorial, where I'm going to change the anchor point from the top left corner of the square to the middle part, and you'll see why. So we'll start by, how about just drawing out the rectangle. We're going to set x to be equals to width divided by 2 and y to be equals to height divided by 2. And how about we set the size to be, let's do 200. We're going to draw it in the middle of the canvas with the size of 200. All right, and you can see that right now it is still anchored at the top left corner, right? So what we need to do is that we need to change the rect mode to center. And then now, this point here, x and y, is at the middle point of the rectangle or the square. The reason that I want to do this is because to rotate the rectangle or the square here, what we need to do is that we need to use 2 transformation functions, translate and rotate. And the rotate function rotates around the origin point. So what we're going to do is that actually, instead of drawing it based on the x and y point here, we're going to first move the origin point from the top left corner here to this middle point here using the translate function. So we're going to translate it by x and y. And if we click run now, it's not going to work the way we want, because what we want is that we want now the origin point to be this point, right? So we can draw the square at the coordinate 0, 0. And then now we can use the rotate function. And the rotate function rotates around the origin, which is this point here. And how about we rotate by, let's say, pi divided by 4, or 45 degrees. And as you can see now, we can do it using the translate and the rotate function, and it rotates around the origin point. And how about we set this to angle, and we're going to declare angle to be equals to 0, and then we're going to update the angle by an increment of, how about 0.01. Alrighty, so now we have a way to rotate the square. Now it's time to draw the arcs. So there are 2 patterns for this quarter circle Truchet tiles. One is going to have a quarter curve in the top left and the bottom right corners, and then the other one is going to be on the opposite side. So let's start with the first version. So I'm going to comment the angle here. We're going to draw an arc using an arc function, which takes in a total of 6 arguments. The first 2 are the x and y of the circle that will make that arc. The 3rd and the 4th are going to be the diameter or the size. And then the 5th and the 6th are going to be where the arc starts and where the arc ends. So this point is 0, 0. So we have to do negative size divided by 2 and then negative size divided by 2. So we want this point here as the center of the arc. So negative size divided by 2, negative size divided by 2, and then we give it the size, which is the diameter of the circle, and then the start and the end of the arc. So it's going to start at 0, and here it's going to be pi divided by 2. So 0 and pi divided by 2. Ta-da! All right, so I'm going to do no stroke here first for the square, and then how about we draw the stroke for the arc. All right, now let's do the next one. So the next one is going to be this arc right here. So the middle point is going to be what? Size divided by 2, and then size divided by 2, right? Third and fourth arguments are going to be the same, but the starting point and the ending point of the arc is different. So it's going to be this point to here. So this is pi, and then this is 3 pi divided by 2. So pi and 3 times pi divided by 2. Nice. All right, so let's uncomment this just to make sure that this arc rotates properly. Alrighty. Okay, so let's do the other version. I'm going to comment this out, and how about we just copy one of these, put it here. All right, so what we want next is we want a pattern here and a pattern here. I'm going to start with this, how about bottom left. So this point here is going to be negative size divided by 2, and then positive size divided by 2. And the arc is going to go from this point here, which is 3 times pi divided by 2, and it's going to end at 0, which is here. I think you can do both 0 and you can do 2 pi. Let's try both. 2 pi works, and 0 should also works. Yeah. All right, so let's do the top right one, which is going to be size divided by 2 and negative size divided by 2. And then the starting point is here at the bottom, which is pi divided by 2. And then this point here is going to be pi. All right, and rotates properly. So what we're going to do is we're going to create a variable. Let's call it type, and type is going to randomly pick which version it's going to be. So how about we use a random function, provide in 2. So the random function can take in arguments in different ways. If you put in 2, it's going to randomize or output a random number between 0 and 1.99999. And what we want is we want a number between, not between, just 0 or 1. So I'm going to use a function called floor so that it turns a decimal point into an integer. So now type is going to be either 0 or 1. And then we're going to write a conditional statement that says if type is equals to 0, then let's do this and uncomment it, and else, then let's do these. I'm going to comment the angle just to show you that it changes randomly. Yeah, perfect. Next, we're going to put it inside a class. So let's come to this arrow here, click the plus sign, click create file. Let's call it tile.js. And then we're going to go to index.html first, and then we're going to link the JavaScript file into this page here. So we just need to change the name here to tile.js. All right, so now it's linked. Inside the tile.js file, we're going to write the word class. Let's name it tile, and then we're going to write the constructor function. And for the constructor function, we're going to put in what? The x and y location of each of the tile. I think I'm going to set size as a global variable. Okay, let's put in, so it's going to be this dot x equals to x, this dot y equals to y. I'm going to put in x and y here. We also want type, but type is going to be, let's just randomly pick it inside this class here. And then what else do we need? Type angle. Angle. So how about we start angle at 0. And then I'm going to write 2 more methods here inside this class. Let's do display and update. So update is going to be just updating the angle. So inside draw here, let's copy and paste all of these. All right, so for display, we want all of these, but the angle incrementation here can be inside update. All right, and then we need to make sure we do this dot for everything. This dot, this dot, this dot, this dot. Size can stay as is because it is a global variable. All right, this dot type also needs this dot. I think that's it. Let's try to create one tile. Okay, so let's do tile, and tile is going to be a new tile at, how about same position as this? So width divided by 2 and height divided by 2. I think those are the two variables we have, right? Yeah. Okay, and then we're gonna do tile.display, run, still the same. And then let's do tile.update, run. All right, it rotates. Let's make a bunch of them. Okay, so let's do tiles as an array. And then I'm going to bring the size up top here and create columns and rows as variables. And then inside setup, we're going to calculate columns as the width divided by size, and then rows as height divided by size. Now we're going to create a grid of rows and columns. So we're going to use a nested for loop that goes through I equals 0 to I less than columns, I plus plus, and then j equals 0, j less than rows, and then j plus plus. And to create a 2D array, what we need is inside this outer loop, we're going to populate this tile array with a bunch of empty 1D arrays, and then inside here we're going to set tiles of I and j to be equals to new tile objects. But instead of having it at the middle of the canvas here, we're going to do x and y, and then how about we set x to be equal to size divided, no, I times size, right? And then y to be equals to j times size, and this way they are placed evenly one after another. And now we also need this same nested for loop to call the update and the display method. So inside here, it's going to be tiles of I and j dot, let's just do display first. Ooh, not correct, and that is because why? Let's go back to tile here. As you can see, we're using transformation functions here, translate and rotate. And every time that we do that for multiple objects such as this, if we don't save and return it back to the default mode, then the transformation start from wherever it leaves off. So what we need is are two functions, push and pop. So push and pop do exactly that. Push saves all of these transformations, and then pop returns it back to the default mode before it calls the transformation again from the original point. So now if I click run, all right, it works, but as you can see, there's some gray area here, and that is because of our X and Y position here. Because the rect mode is now at the center, we need to also offset it by size divided by 2 for both of these. All right, let's make this to be about 40. Okay, if I click run multiple times, you can see that the patterns change. Great. Now we are ready. Are we ready to update it? Nice. So we're pretty much done. Now we're going to add some interactivity, but before we do that, we're going to have it rotate at a non linear manner. So right now it is rotating linearly. So it is rotating incrementally, right? Because we have this update function that basically rotates it at 0.01 like radians. I totally missed what that was. Radians per frame, right? But what we want is we want it to ease into it. We want a more organic movement, and to do that we're going to use easing functions. So how does that work? So if you come to this website, here are some of the easing functions. And with easing, we change the rate of change from linearly to something non-linear. So instead of moving evenly from start to end, easing allows us to control how the transition happens. And in our case, input to the easing function is time, which increases each frame 60 times per second, right? And so the function returns a value between 0 and 1 based on that input, and we use that to map to something that we want to animate, and in our case, it's the angle. And to use the easing functions, we can basically just copy whatever easing functions that we want to use, but I have compiled easing functions based on this website, easing.net, into this file, so you can just come to my code and then copy it. So what we're going to do is add a new file here. Let's call it easing.js, and then inside index.html file, make sure that you also link it to the program. So easing.js, and then ta-da! Now we have all the easing functions. Let's go back to tile. What we want to do is now we want to update this update function, and we're going to basically increment the amount, right? The time instead of the angle, but we're now going to set the angle to be equals to one of the easing functions. So how about we do this one, ease in out quad. So it starts slow, ramps up, and then slow down at the end. And then we want to input in something that we're going to use to increment. So let's do this.amt, and then we want to map it to the one revolution that we want it to rotate, so 2 pi. And we need to set this.amt to be equal to 0. And then we also need to increment this.amt. Let's do it by 0.01 again. Ooh. Whoa. Okay, why is that happening? It is because the amount that you can input inside this function is between 0 and 1. So what you want to do is also write a conditional statement that says if this.amt is greater than 1, then reset it back to 0. And that should fix the issue. You can see, right, that it starts fast, slow down. No, the other way around. Slow down, ease in, and then fast, and then slow. All right, so you can play around with different easing functions to get the animation that you want. One more thing that I want to show you before we move on is that, let's say that I want to only rotate it by, how about pi divided by 4. But now the starting point is at 0. So you can see that it goes back to the original point. So what we also want is that when it is 1 revolution, then we want to continue from where it ends. So what we need is that, how about we create a new variable called starting angle, started at 0. So once it completes 1 cycle from 0 to 1, then we set this dot starting angle at whatever increment is, which is 1 revolution or 1 cycle that you want it to rotate, and then we just add it to here, starting angle plus, and then now you can see that it ends at a quarter each time it rotates. All right, but I still want it at 2 pi, so I can just do 2 pi here. This is a little bit redundant now, but now you know how to do that if you need to. So now let's make it interactive. So what we want to do is that we want to make it only rotate when the mouse hovers around that area. What we want to do is that we want to calculate the distance between the center of the tile and where the mouse is. So we're going to, how about create a variable called distance. And to find the distance between the mouse location and the center of the tile, we can use a function called dist, which basically takes in 2 points and then, or for x and y coordinates, 2 sets of x and y coordinates, and then find the distance between those two. So it's going to be mouse x and mouse y, and then this dot x and then this dot y, right? And then we're going to write a conditional statement that says, if distance is, let's say, less than hover distance, and then how about we go to sketch to set what that hover distance should be. Let's say, let's do 15. And then if it is close enough, then we want to animate it. So we're gonna write a Boolean, we're gonna create a Boolean variable. Let's call it is animating, set it as false. And if this conditional statement is true, then we're gonna set this dot is animating to be equals to true. And then if this animating is true, then we're going to be updating this dot amt here. This dot angle will be outside because we're gonna set the angle as to whatever it is, regardless of the conditional statement being true or not, right? Alrighty, let's try it. Nope. Oh, is animating. All right. But then now it continues to rotate, and that is because we also want to make sure that once it completes one cycle, then let's set this dot is animating to false. All right. Or if you want them to continue to animate, you don't need to set it. It's your choice. Alrighty. Okay, now let's add some colors. So we're going to, how about set a new variable called C, and I'm going to randomize the color based on a specific palette. So the palette that I want to do is going to be called colors, and colors is going to be this palette here. And now inside tiles, I'm going to randomly pick an index. So we're going to do a random of colors.length, right? So the length is going to be whatever it is, and then we're going to use floor to get an integer, and then we're going to use this index number to get the color. So color of this number. And then inside inside display, we're going to do stroke of this dot C. I'm also going to set the stroke weight to be a little bit thicker. Let's do, how about 4? Click run. All right. 2 more things. I want to change the color of the tile to be this. Okay. And then how about let's change the background color to be this color, light yellow, and I'm going to make the size to be smaller so we have a bunch more tiles. Click run. And you can change the hover size as well, so that if, let's say you change to 5, yeah, different aesthetics. All right, that's it. This combines 3 of my past tutorials, and it gives you this fun display to play with, and I hope that you enjoy it and give it a try.